Good morning. Let's start by getting logged into Clever. All right, so let's get things going. Tell me something that you do, or a day, or something that happened that made you super proud of yourself. Great. So, this is live lesson 14, and this is a really important one because we're going to walk through how to do your assessment for Unit 1. Holy cow. So a couple reminders, grades have to be in like today. So please make sure that you're getting all of that work done. If you notice that there's something that I have missed grading, put a comment in there because that pops up right away on my phone and I can grade it. Make sure that you check and see that if I've returned something to you because it wasn't done correctly, or if you didn't finish the ed puzzle all the way and so your score wasn't recorded, just make sure that you're paying attention and getting those things done. Remember our expectations of being respectful, prepared, here, safe, and responsible. Make sure that we are really trying to come to the live lesson and following those expectations as well. And again, making sure that we're fully caught up on our first 6 weeks of grades. All right, so today we're focusing on getting ready for our first test. Number 31, Big Bang, Origins of Matter and Energy in the Universe, Assessment and CER. We're specifically going to talk about how to do the CER, and we're going to essentially practice exactly what it is that you're going to have to do. So let's start with just about 5 to 10 minutes of some review about what we've been talking about these past 5 weeks. So the central question we've been focusing on is understanding where all energy and matter in the universe comes from. And we started by using this kind of phenomenon of this guy, Carl Sagan, talking about the universe. So start by, what is something you remember about him? So many of you guys remembered that he talked about how the sun and the stars are super important because we are star stuff, or we are the children of stars. And at first, a lot of us didn't fully understand what that meant. But we then spent some time breaking this down so that we can understand why we are star stuff. Why we are the children of stars. So we first thought about, where does all energy come from and how does it change? So what do we remember about where energy comes from and how it changes? So if we remember, there are lots of different types of energy. So we did the Colorado FET, where we thought of and analyzed all the different types of energy that we might see. We then thought about how energy is conserved because energy may change forms, but it has to come from somewhere. So energy is converted, but it never just appears or disappears. The law of conservation of energy states that energy cannot be created or destroyed. It just might change form. We talked about how the sun on Earth is a super, super important source of energy because the sun releases lots of energy that our plants particularly use and help to create an environment where we can live. We also talked about how energy can be tied back to the Big Bang. The Big Bang being this event that created and started everything about 14 billion years ago. So, next question is then, where does matter come from and how does it change? So, many of you guys brought up how matter also has to be conserved. So, matter can change the form that it's in, but it has to come from somewhere else. And some of the changes could be physical, so changing an outward appearance, chemical, where you're changing the molecular makeup. So you're making a new substance, but with the same atoms that you had at the beginning. And then the biggest one of this, the one that is most substantial with what we're talking about, is nuclear changes, where you are changing the matter by changing the atoms. Okay. And specifically, we discussed fusion and fission. So fission is one that we see here on Earth in the form of like bombs and power plants. But in the sun and other stars, fusion is what creates larger atoms. So by taking two smaller atoms, bringing them together to make a larger one, and it releases lots and lots of energy. So that ties back to why the sun is so important in producing energy. Okay. The Big Bang also is where all of our matter can be originated from. So that is what kind of forced us to start to think about this timeline, where the Big Bang occurred about 13.8 billion years ago. And in the first seconds and minutes, particles started to form. They started to come together and to form our first atoms. Now, it took a couple 100 million years to start for our atoms to start to form and get into larger atoms that then came together to form stars and galaxies. That took a couple 100 million years, not just 100,000 years. And it took a couple of billion years for those then to separate and expand into actual galaxies. Now, our galaxy and our solar system and our sun and our planet Earth formed about 4.5 billion years ago, with life beginning about or first life beginning about 2 billion years ago. Okay. So we then talked about the three pieces of evidence that help support the Big Bang actually happening. One is the fact that there's this leftover energy and radiation that has been stretched out as the universe has expanded that can be traced directly back to the Big Bang. And that's called cosmic background radiation, or you might hear it called cosmic microwave background. The second piece of evidence is Big Bang nucleosynthesis. So, most of the universe is made up of the most simple atoms, hydrogen and helium. And those atoms would have been the atoms that were made right after the Big Bang because they are the most simple. And then the third piece of evidence is the fact that when we look at distant galaxies, over time they are doing what we call is red shifting. So that means that their wavelengths that they are releasing that we can see back on Earth are becoming bigger and appearing more red. And what that means is that the universe continues to this day to expand. Okay. And that's a key component of the Big Bang Theory. So now, with all of that understanding, use one of these sentence starters, either if then or we are considered star stuff because, bring it all together and explain why we are considered star stuff or the children of stars. Awesome. So if you're feeling comfortable with all that information, be ready to jump ahead and move forward. If you need to pause and you need to go study your Quizlet a little bit more or look at another assignment, pause this real quick, go back and do a little work. Because if you feel good with all of that information, then you are ready to go with this assessment. Okay, so the assessment is in two parts. One is a multiple choice multiple choice questions on Google Form. There are 12 total questions. It is going to be out of 10, so that means that there are 2 bonus questions there. Half of them are kind of like the check for understanding questions that we've been having regularly. The other half are a little bit more detail oriented and are asking you to analyze some evidence and some text to answer questions. Now, the second part of this is the CER doc, and that is what we are going to practice doing together today. So a CER stands for claim, evidence, and reasoning. A claim is a statement of belief. Evidence is the data or facts or information that you use to back up that claim. And then the reasoning is where you tie together the claim and the evidence, where you explain why the evidence supports the claim that you made. So for your CER, you're not actually really writing a CER. We're going to get there later on in the year because you will have to do that a lot next year in biology. But what we're going to start off with is an activity where you have to identify the claim, the evidence, and the reasoning in 3 different people's statements about the Big Bang. So the process is this. You're going to read the statement very, very carefully, and you're going to highlight the claim in all 3 statements, the claim in green. You're going to find the evidence that they use in each of the statements, and you're going to highlight that in yellow. And then you're going to highlight the reasoning of why that evidence supports the claim in blue. So we're going to do this as a practice together. So this is a statement that is not on your test. This is completely different, but it's very, very similar to what you're going to see on your test. Okay. So let's start with this. You can't highlight it like we would in the Pear Deck Live version of this, or like you're going to do on your CER. But please choose what is the claim. The Big Bang did happen approximately 4.5 billion years ago. The Earth and Sun are made of the same types of elements found in faraway galaxies, so they must have been made at the same time, as proven through Big Bang nucleosynthesis. The Earth and Sun are the two most important and influential celestial bodies in the universe, so they tell us when the whole universe must have started. All right, so like I said, you need to identify the claim. Does Rowan think the Big Bang didn't happen, or does he think it did happen? Great. So Rowan clearly said, and you should have highlighted and identified that the Big Bang did happen. So now you need to go through and find out which piece of evidence is he using to make that claim. All right. So there are, again, are three pieces of evidence: cosmic microwave background, Big Bang nucleosynthesis, or redshifting of galaxies. So which piece of evidence is Rowan using to make his claim that the Big Bang did happen? Awesome. So he is using Big Bang nucleosynthesis. All right. So the next piece of this is we need to explain why his thoughts about Big Bang nucleosynthesis, or we need to identify it, why his thoughts about Big Bang nucleosynthesis resulted in him making the statement that the Big Bang did happen. All right, so that one was a little bit tougher to be able to identify. So really, it usually you can find the evidence at the end. But also, I wanted to include so what Big Bang nucleosynthesis is saying is that the elements that are found now were also found at the Big Bang. But here, his reasoning is that the sun and the earth are important, and they will tell us when the universe must have started. Okay, so now looking at that as a whole, you're going to, on your document, you're going to highlight in pink either yes or no if you think that his statement and his use of the evidence is correct. Okay, so just tell me right now, do you think Rowan's understanding of the Big Bang and the evidence to back it up is correct? So I think I tricked a bunch of y'all because it is actually incorrect. All right. And so the piece that you're going to do next is you are going to analyze their claim, evidence, and reasoning, and you need to determine why it is correct or why it is incorrect. Okay. And what you're going to do is you're going to back that up with stuff and information that we did during class. So here I have a list of some appropriate places that you could cite and that you could recall in your analysis of what they said. So right here, what is wrong with his thinking? Make sure to include some tie back to one of the activities we did in class. Great. So here's what I put. The Big Bang did occur, so he was right on that front, but his reasoning is where it's messed up. But cosmic microwave background dates the formation of the first elements, hydrogen and helium. Yes, they are found in our star and on Earth, back to almost 14 billion years ago. Okay, Rowan said 4.5 billion years ago. The Big Bang events timeline, that's what I'm citing to show and prove my idea, showed that data supports that our sun and Earth were not the first sun and planet, or star and planet in the universe, let alone in our galaxy or even solar system. Both were formed around 4.5 billion years ago. That's far after many stars had already lived and died. Okay, so the major issue is that the timing that he's saying is wrong. The Earth and the Sun are not at the center of the universe, and they were not the first things to be created after the Big Bang. Especially cosmic microwave background that is almost 14 billion years old, tell us that there was stuff way before our Earth and Sun even was formed. All right, so the next step here is I just want you to make sure that you can find and access both of these documents. Again, one, the multiple choices in a Google form, and then the second one, the CER, is in a doc. So you are going to start by finding the claim for each person and highlighting it. So if you don't know how to highlight, you're going to use your mouse to select the text, and then to highlight it in a color, you click on next to the text color. There's this little kind of marker looking button that's highlight, and then you choose the color. Again, following the directions, it's green for claim, it's yellow for evidence, and it is blue for reasoning. Okay. So those are your next tasks. Again, this is the last assignment for this first unit. Next week, we're going to start moving into talking about our next unit topics. Good luck. You guys are going to do great. And I believe in you, and I hope that you feel prepared and are ready. So finish off with this. How are you feeling about this assignment or this particular assessment? And that's all I have for you. Have a wonderful day. Thank you for taking the time to get prepared for this test as best as possible. See you later, and bye.